Good morning, one and all. Today we shall start with Unit 1 of your syllabus in the C Programming for Problem Solving course. This is the outline of this unit. These are the topics we are going to cover in this unit. First, we'll be discussing Introduction to Digital Computer, where we'll be looking into the functional units of a digital computer. Before that, we shall try to define what a computer is, what are the functional units of a computer. And then we'll discuss a few things with respect to hardware and software, how the software is classified, what you mean by programming language, how actually the computer programming languages are classified. So this is what we are going to discuss under software. Okay. So after that, we'll be looking into the representation of algorithms and flowcharts. So these are the two design methods that we can use to solve the given problem. So what do you mean by an algorithm? What actually mean by a flowchart? So what are the notations and the symbols you can use to write the algorithm and flowchart? We are going to discuss with example. Okay. After completing these topics with respect to there is the introduction to digital computer, we'll be looking into C programming aspects after these topics. Okay. We'll first look into the features of C programming language, and then we'll discuss the structure of a C program. So any C program you write, it will be having a mandatory function, that is the main function. So in addition to that main function, what are the other sections you find in a C program? We are going to discuss with example. Then we'll look into the phases involved in executing a C program. After that, we'll discuss the basics of C programming language, the constructs like constants, variables, and data types. What actually mean by C tokens? What are the C tokens supported in C? So all those with examples we are going to discuss. So once this is done, we'll be looking into the input and output operations, how actually these operations are handled in C programming language. So what functions are supported in C to perform these IO operations we'll be discussing. And finally, the last topic which we'll be discussing in this unit is C operators and expressions. So what do you mean by an operator? What actually mean by an operand? What do you mean by an expression? How actually the operators are classified in C based on what this classification is done. With examples, we'll be discussing all the operators and their precedence and associativity. So what do you mean by precedence, associativity? Why you need these in evaluating an expression? With example evaluation of expressions will be discussing. So this is the outline of unit 1. We'll be starting with introduction to digital computer. Once we discuss these three concepts with respect to digital computer, we'll be looking into the C programming language. So first, coming to the definition of a computer, how to define a computer. So we can define formally a computer as a fast electronic calculating machine that accepts digitized input information, processes it according to the list of internally stored instructions, and produce the resulting output information. So this is how we can define a computer. So what is a computer? It's a fast electronic calculating machine. What computer does? It accepts the input. So whatever the input it accepts, it will be converted into digitized form, that is binary form, what we can say, that has zeros and ones. Then it is going to process that according to the list of internally stored instructions. Processing, that means, so once we say it accepts the digitized input information, that means input unit comes into picture here. See, the functional units of a computer are actually used in this definition. That is the input unit, which is used for feeding the input to the computer. Then the processor, the central processing unit or the processor, what I mean to say, which processes the instructions which are stored in the memory. So in which memory the instructions are stored? It is actually the RAM memory, which is called as random access memory, where the instructions of your program are stored. So processor is going to take the instructions which are stored in the memory one by one, and it is going to process that instruction or execute that instruction, and then it is going to produce the resulting output information. So that output information will be sent out to the outside world using output unit. So these are the important terminologies you need to know with respect to a computer. A computer is a fast electronic calculating machine which accepts the digitized input information, then processes it according to what? List of internally stored instructions, and then it is going to produce the resulting output information. Okay. So internally stored instructions means memory we are talking. That is in specific, it is main memory. The example is RAM, random access memory, where the instructions of your program will be stored. So any program to be executed, it has to be residing in the main memory. Okay. Informally, we can just define a computer like this. Computer will accept the input, processes it, and produces the output. In simple terms, this is how we can define a computer. So formally, how to define a computer? That definition we are seeing on the slide here. Okay. So this is about definition of a computer. Coming to the functional units of a computer. So, as already mentioned in the definition, what are the important components you find in a computer or functional units? So, actually, they are functionally independent parts of a computer. What we are seeing here, one is the input unit, the other is the system unit. In turn, the system unit is having two components: the CPU, which stands for Central Processing Unit, and the memory unit. Together, we call this as a system unit, and finally, the output unit. So totally five functionally independent parts we are seeing in this block diagram. Okay, what are those five functionally independent parts? One is the input unit. Then in the CPU, you are having ALU, control unit, and the memory unit and the output unit. Now we'll see one by one the functionality of each of these functional units. Okay, coming to the input unit. So what is input unit? It is actually an external device. What is the purpose of using an input unit? It is used for transferring the information. That information may be a data or it may be an instruction. So we are going to transfer the information to the system unit using this input unit. So the standard input unit is keyboard. Keyboard, mouse, scanners, a few examples of input unit. Keyboard is the standard input unit. Okay. So what is the input unit? It's an external device which is used to transfer the data and instructions to the system unit. So to perform this operation, so the core of the computer is actually the control unit, which is responsible for supervising all the operations in a computer system. We call computer as a system. That means it is having other interconnected components which are used to perform the operations. What are the operations a computer can perform? It can accept the input, it can process the data or the instructions stored in the memory, it can just produce the output, and it can store the information in the memory. So these are the different operations or functions performed by a computer, right? What are the functions? Input, processing, output, and storage. So a computer is a system with interconnected components that perform the basic system functions. What are the basic system functions a computer can perform? It is input, processing, output, and storage. So input is handled by the input unit. To perform this, control unit is responsible. As I told, any operation you perform within a computer, control unit is responsible for controlling and coordinating all the activities in a computer. So if some input is to be read through the keyboard, then control unit has to send the control signals to the input unit so that the input can be read through the keyboard and it can be fed to the system unit. Similarly, if some output is to be displayed onto the monitor screen, where monitor is the standard output device, control unit has to send the control signal to the output unit. So to communicate between the IO devices, control unit is required. Or it may be communication between the processor and the memory. So CPU stands for Central Processing Unit. So for communicating between the processor and the memory also, this control unit is used, where control unit sends the signal to the memory unit. So if some read or write operation is to be performed. So assume some instruction is stored in the memory. So that instruction is to be fetched by the processor to execute that instruction. And as you know that the program to be executed must be loaded in the memory. So one by one, the instructions will be fetched from the memory into the processor, then it will be decoded and executed. So this is the normal procedure involved in executing any instruction of your program. The program which resides in the memory is to be fetched, decoded, and then it has to be executed. So who is the component, or which is the component that is responsible for executing the instruction? It is the processor. Okay. Through the input unit, input is fed to the system, and whatever the program you are having or whatever the program instructions that are read, that will be stored in the memory. One by one the instruction is fetched from the memory and it will be decoded and executed by the central processing unit. So these are the components which we are having. And what you need to remember is control unit is responsible for all the activities, for controlling or coordinating all the activities in the system. Say from we want some instruction is stored in the memory. We want to read that instruction from that location, and that is to be transferred to the processor. So in that case, the control unit sends out the read control signal, and also it sends out the address from which location the instruction needs to be fetched. So this is how it is going to initiate the read operation. Okay, how the processor initiates the read operation? It sends out the address or the location from where the instruction or the data is to be fetched, and it also sends out the read control signal to perform the read operation. Similarly, if you want to write some data, so within the processor some data is there, you want to write that data to the memory at some location. So in that case, processor will send out the address to which location the data is to be written, and also it sends out the write control signal. Okay. So similarly, if some ALU operation is to be performed, ALU stands for arithmetic logic unit, which is the component within the processor for performing arithmetic logical operation, or the execution of the instruction takes place within the ALU. Okay. So to perform any of the arithmetic operation, control unit has to send out the signal. Okay. So if some addition operation is to be performed, then control unit sends out the that is add control signal. So and so on. Okay. So arithmetic logic unit is the hardware circuitry which is responsible for performing arithmetic and logical operations. So what you have to remember is the 5 functional units of a computer, which are functionally independent parts. So these interconnected components makes the computer as a system as a whole, okay, and it makes the computer operational. Okay. So this is the input unit, what we have already discussed. Example, keyboard, mouse, scanner, etc. Keyboard, remember, it is the standard input device or input unit. Coming to the system unit. So in system unit, as I told, what are the two components you are finding in the system unit? That is the CPU and the memory. So what is the purpose of the CPU? So whatever the instructions that are stored in the memory, so that will be fetched and it will be decoded and executed. Okay. So once the instructions are received from the input unit, they will be stored in the memory and it will be processed in this system unit, that is the CPU. So CPU, as I already mentioned, it stands for central processing unit. So in turn, the CPU consists of two functional units. One is the ALU, arithmetic logic unit, and other one is the control unit. So what is the purpose of ALU? That is, it is responsible for performing arithmetic and logical operations. So whenever we just the operands are brought into the processor, so where the operands will reside, or if an instruction is fetched from the memory, I told the procedure involved in executing an instruction of your program. What is the procedure involved? The program will be residing in the main memory, and one by one the instruction will be fetched into the processor. It will be decoded and executed. Okay. So once the instruction is fetched into the processor, or once the data is fetched into the processor, where actually that resides in the processor? So this is the question. So where it resides is, it will be stored in a high speed storage element which is called as a register. So CPU, each processor you take, it will be having some set of registers supported for the processor. Okay. So whatever the data or instruction you fetch from the memory, that will be stored in the register. Since the registers reside within the processor itself, performing our access operation will be faster. Okay. So this is one point you need to remember with respect to the processor. The instruction or data fetched from the memory will be stored in a high-speed storage element, which is called as register. Coming to the ALU, I've already mentioned, for performing arithmetic logic operations, ALU component is used. Once the instruction is decoded and it comes to know that some addition operation is to be performed, The operands on which the addition operation is to be performed will be sent to the ALU component. So this is the circuitry which performs the addition operation, and the result of addition operation will be sent out, or it may be stored in the register within the processor, or it may be written to the memory. So depending on what instruction you have written, accordingly the instruction will be executed. Say for example, you'll write add R1 comma R2, where R1 and R2 are the registers of the processor. So once the processor decodes that instruction, so decoding means it interprets that instruction to find out what is the operation to be performed. Say addition instruction is fetched from the memory, and after fetching, processor will decode that instruction to find out what operation is to be performed. And once it finds out the operation to be performed, that is add, it checks whether the operands are residing within the processor register or operand is to be fetched from the memory. So if the operands are residing in the register itself within the processor, then it sends out those operand values to the ALU. ALU will just perform the addition operation, and it sends out the result. So if the result is to be stored back in the register within the processor itself, it writes it. Or if it is to be stored in the memory, then you know how to communicate to the memory. So it sends out the address. This is taken care by the processor. Processor sends out the address to which location the result is to be written, and also it sends out the write control signal, that is taken care by the control unit of the processor, and accordingly the data will be returned to that specified location. So this is about ALU and the control unit. So remember, control unit sends out the control signals to the various components of a computer system, and it controls, or it just supervises the overall operation of the computer system. So what are the functions performed by the control unit? So it is responsible for fetching the data and instructions from the memory. So read write control signals will be sent, or it may be the for controlling the operations of IO devices, maybe the transfer of data into the system unit or from the system unit to the output unit, okay, or maybe to perform the arithmetic logical operations, or to decode the instructions. So everything will be handled by the control unit. So it is responsible for overall supervision of the computer. So this is about the control unit. So what is the responsibility of the output unit? It is the actually the counterpart of the input unit. What is the functionality? It is to whatever the processed result you're having in the processor, so that can be sent out to the outside world using the output unit. The standard output devices, monitor, other output device, say printer, etc. Okay, so this is about output unit. Some other major functional unit in the computer is memory unit. Okay, so memory unit, it consists of two types of memory. So what are the two types of memory? It is the primary memory or the main memory, and the secondary memory. What is the purpose of primary memory? Actually, this primary memory is meant for storing the instruction of your program which are to be executed. You can say any program which should be in the state of execution, that should reside in the primary memory. So what this main memory means, remember I'm talking with respect to RAM memory, random access memory, which holds the program which is to be executed by the processor. So what this main memory is made up of? It is large number of semiconductor storage cells, what we say, where each cell is capable of storing one bit of information. So the memory is made up of semiconductor storage cells. Each cell can hold only one bit of information. That bit can be either 0 or 1. Okay. And coming to the secondary memory. Why we go for secondary memory? So remember, primary memory is actually limited and it is expensive. So if you want to have, and one more disadvantage is the primary memory, it is temporary memory. It is volatile memory, what we say. So once the power is turned off, or the system is turned off, the contents of the primary memory, that is RAM memory, will be vanished. So if you want persistent storage of the data or instructions, okay, then we can go for huge data storage. These are the two reasons: huge data storage and persistent data storage. Then we can go for secondary memory. which is less expensive compared to primary memory. So just remember these points with respect to memory. Memory unit consists of two types of memory named as main memory and secondary memory. Primary memory or the main memory, it operates at electronic speeds. It is made up of semiconductor storage cells where each cell is capable of holding one bit of information, and the program that is to be executed must reside in the main memory. Okay. Although this primary memory is expensive, we'll go for secondary memory, the additional memory, which is cheaper compared to the primary memory. Reason we go for secondary memory, for persistent and huge data storage, we'll go for secondary memory. Okay. So this is about the functional unit of a computer. See, these are the five functional units of digital computer: input, CPU. Within that, we are having two major components: ALU control unit, memory unit, and the output unit. We just discussed the responsibility of input unit, output unit, ALU, control unit, and the memory unit. So memory, it is classified into primary memory and secondary memory. In primary memory or main memory, we discussed about only the RAM memory. There is one more primary memory that is called as ROM, that is read-only memory. As the name itself indicates, we can perform only the read operation from this memory, whereas RAM memory, random access memory, it is a read-write memory. We can perform not only the read operation from this memory, we can also perform the write operation to the memory. So that is RAM memory. RAM is volatile, means once the power is turned off, the data stored in that memory will be lost. Whereas in ROM memory, it is non-volatile. Data stored in that will be retained even though the power is turned off. Okay. So what is ROM memory? The primary memory consists of, it is actually BIOS routines. So several peripherals will be connected to a computer system. So for proper functioning of these peripherals, so there will be some small routines loaded in this ROM memory, and also a boot program. What do you mean by boot program is, once you turn on the system, the operating system gets loaded to the main memory, so, or the primary memory, that is the RAM memory. So who is responsible for loading, or how it is loaded? That is, there will be a bootstrap loader, a program, a small routine that will be available in the ROM memory, which helps in loading this operating system to the RAM memory. Okay, the BIOS routines and the bootloader program. So all these will reside in the ROM memory, which is non-volatile. Okay, so remember at least these differences between RAM and ROM memory. Both are primary memories or main memory. So what is stored in main RAM memory and what is stored in the ROM, and whether it is volatile or non-volatile. Kindly note the difference between these two with respect to these constraints. Okay. Coming to the hierarchy of memory, so all these I've already discussed. The functional units explanation I've given. This I'll share it so that you can go through it from internals and exam point of view. So this can be simple memory hierarchy. Just see, first comes the CPU register, and then comes the cache memory, then primary memory, and secondary memory. I have listed the difference between these memories with respect to these three constraints: size, speed, and cost. Okay, and this is increasing. Whatever the directed arrow you're seeing, so starting from CPU register. So compared to CPU register, size of cache memory is more. Compared to cache memory, primary memory size will be more. Compared to primary memory, secondary memory storage capacity will be more. So this is increasing with respect to the size. With respect to the speed and cost, so we can see here the speed of secondary memory is slower compared to primary memory. Similarly, compared to primary memory, cache memory is faster, and compared to cache memory, CPU register, accessing CPU register is faster. And with respect to cost, so you can just see the direction. So with respect to these three constraints, you can give the differences between CPU register and cache, or CPU registers and primary memory. Between any two memory components, if they ask you the differences, you can list out the differences. Okay, so just know that with respect to capacity, this is order. You can hierarchy. You can just find out. CPU register, then comes cache memory, then comes primary memory, and finally the secondary memory. So we already discussed what is stored in the primary memory and secondary memory, and or when we go for primary and secondary memory. So we are seeing one more memory, that is cache memory. So there may be two types of caches. It may be the cache memory may be built in within the processor on chip. It may be available, or it may be external cache available. So cache memory, what it stores is it will be storing most recently used data and instructions. So assume the as and when the instructions are fetched from the primary memory, a copy of that will also be stored in the cache memory. So next time, if the same instruction is required by the processor, then it first tries searching for that instruction within the cache memory, so that the access time taken will be less. Okay. So what cache memory holds is the recently accessed data and instructions will be stored in the cache memory. Capacity is less compared to primary memory. Okay. So this is about the memory hierarchy. So just to show you how actually these different memories differ with respect to size, speed, and cost, I've just put this simple diagram. CPU register, then comes cache, then comes primary, and finally the secondary memory. Okay. Coming to the units for measuring the memory. So these are the standard units which we can use for measuring the memory. 1 KB, which stands for 1 kilobyte, which constitutes 2 to the power of 10 bytes. That is nothing but 1024 bytes. Okay. 1 MB, which stands for 1 megabyte, which constitutes 2 to the power of 20 bytes. You can also tell it as 1024 kilobytes. If you are writing in capital letter KB, it is byte. Okay. If you are writing in lowercase, it will be bits. So just note the difference between bit and byte. Here it is 1024 bytes. Okay. So one in one memory location, I'm not talking about the cell. One memory location, 1 byte of data can be stored. 1 byte data means 8 bits. Sequence of 8 bits. We are going to call it as 1 byte, and this convention will not change any processor you take. So it may be any processor, okay, any bit processor you consider. It will be the same convention, or the same meaning holds for a byte. Byte means it is sequence of 8 bits. So at any given time, we can access 1 byte of data from the memory. This is the smallest unit that we can fetch from the memory. That is 1 byte of data from the memory. So each location in the memory will be assigned unique address. Okay. So if we just specify that address, from that address we can fetch the byte data. So that we call it as byte addressability. So unique address is assigned for individual byte locations. So if I say memory with capacity 1 kilobyte means it is 2 raised to 10 bytes. In that memory, there will be 1024 locations, where in each location we can store 1 byte of data. What do you mean by 1 byte? It is sequence of 8 bits. So this is the convention. So 1 KB meaning 1024 bytes. So there will be 1024 locations in the memory. So in each location, 8 bit of information can be written, which is sequence of zeros and ones. So 1 MB is nothing but 2 raised to 20 bytes, which constitutes 1024 kilobytes. So 1024 into 1024 will be the total bytes in that memory. So 1 GB, which is 2 raised to 30 bytes, you can write it as 1024 megabyte. 1 TB, which stands for terabyte, it is 2 to the power of 40 bytes. You can just tell it as 1024 gigabytes. So these are the standard measurement units that we can use with respect to the memory: 1 KB, 1 MB, 1 GB, and 1 TB. Kilobyte, megabyte, gigabyte, and terabyte. Okay. So this completes the functional units of a computer, and we discussed the memory hierarchy and the units we use for measuring the memory. The next topic we'll be discussing is hardware and software. What do you mean by a hardware? So there are these are few several hardware components. CPU, it may be the RAM memory, or it may be the keyboard, the I/O devices, hard disk, mouse, etc. So hardware is nothing but the physical components that make up a computer system. It includes all the input, output, and storage devices. So we already seen the functional units of a computer. So all these physical components which make up the computer system, they are called as hardware. Okay. So this is how we can define an hardware. Coming to the software, what do you mean by a software? It's a kind of a program that enable a user to perform some specific task, or it is used to operate a computer. So this is how you can define a software. Software is nothing but a program. So what is the purpose of that program? Program may be used to perform some specific task, or it may be used to operate a computer. So what do you call that software as, which is responsible for making a computer operational, and what are the softwares that are used to perform some specific task we are going to see in the coming slides. So just know software is a kind of program which enables the user to perform some specific task, or it is used to perform the operation, or used to make the computer operational. Okay. Or a computer system, for managing the computer system or to maintain the computer system, will be using some software which are actually programs. Okay. Coming to the classification of software, these are the two major classifications of software. One is called as the system software, and other classification is called as application software. So as I told, software we use for performing some specific task, or to make the computer operational, or to maintain the computer system, will be using some software. So this is the major classification of software: system software and application software. So first we shall discuss system software. Okay. What do you mean by system software? The software used to control and coordinate computer hardware and application programs, it is called as a system software. Okay. It acts as an interface. We can say it provides the platform. So system software provides a platform for executing application programs. So this is how you can tell, or we can define a system software. So the system software is actually responsible for resource management, whatever the resources connected to the system, for resource management, memory management, file management, language translation. So what do you mean by language translation? We'll be discussing. And system maintenance. So for all this, the system software is responsible. In higher courses, in next higher courses, you will be discussing. You are having a dedicated course named operating system. So one important system software which makes the computer operational. So in detail, you will be learning about the operating system. So what are the responsibilities of an operating system? And each of these responsibilities, there is a memory management, file management, resource management. So each of these functionalities of a operating system will be discussed in detail in that course. Okay, since in this course these topics are out of the scope, will not be going into the details of this. Just know that system software is responsible for resource management, memory management, file management, language translation, etc. Okay. Few system softwares I'll just list here. Examples for system software: operating system, which is the major system software, language translators, utility softwares, etc. Coming to the operating system, it is a system software which makes the computer operational. So this operating system, as I told, it acts as an interface between hardware and the application programs. Okay, it makes the computer operational. Your computer cannot work with this mandatory system software, that is operating system. So it is used to manage computer software and hardware resources. So this is about operating system. You might have heard about several operating systems: Word, okay, disk operating system, it is Windows operating system, disk operating system, Unix or Linux operating system. These are different operating systems. which you might have heard. Coming to the another system software, that is language translators. So what do you mean by language translator? So language translator means it is a system software or it is a translator program, okay, which is used to convert the source code into machine code. So machine code means into binary form, zeros and ones. A program which is responsible for doing the translation or conversion of the source code to the machine code is called as the translator program. A few translators can be listed, say assembler. Assembler is a system software, or you can tell assembler as a language translator, which converts assembly language program to machine language. So this is one translator program. Compiler is another translator program, which is again a software which is used to convert high-level language program to machine-level language. So machine language means it is machine understandable language. Remember, computer can understand only the binary form, zeros and ones. So if you are writing in any high-level language, a program, in that case, it has to be translated to machine language so that the system can understand. So these are few translator programs, and there is one more translator which can be called as an interpreter. So that also converts high-level language to machine language. So these are few language translators which are actually system softwares. Another system software, it is utility software. So utility software means these are the software programs which adds functionality to your computer or it helps your computer perform better. A few utility softwares are disk repair, antivirus, debugger, backup software. So several antivirus, debugger, backup softwares you might have heard. So all these come into the category of utility softwares, which are actually system softwares. Okay. So this is about system software. So we saw the classification of software, system software and application software. We saw that system software, it is actually the major software which makes the computer operational. And what a few example system softwares I've listed: operating system, language translators, utility software, etc. Coming to the application software, it is a software which is created for specific purpose. We can say software for end users. The application software is actually used for specific purpose. Say for example, word processing softwares. Example, you can consider EMS Word, Microsoft Word. Then spreadsheet software, Microsoft Excel, you can consider as an example. Database management softwares, you are having Oracle software, SQL software, Microsoft Access software, etc. So these are a few softwares related to database management. Then graphics and presentation softwares like Microsoft Paint, Microsoft PowerPoint for making the presentations, Corel Draw you're having, Adobe Photoshop, etc. So these are few graphics and presentation software. And web browser softwares like Internet Explorer or maybe Google Chrome, Mozilla Firefox, etc. So these are all application softwares created for specific purpose. Okay, so this is about system software and application software. Coming to the next topic, that is programming languages. So far what we have discussed is what a computer is, what are the functional units of a computer that makes the computer as a system and that makes the computer operational, and then we discuss what we mean by a hardware and software and how the software is classified. We have few examples to discuss. So the next topic we are discussing is computer languages. So what is the use of computer languages? Why programming language is required? If you talk with respect to general language, so, so what do you mean by a language or why language is required? So language is required for communication. So if one person wants to communicate with other person, then you require a language to communicate. So here, computer programming language means it is actually a programming language that is actually used for communicating with the computer. So if you want to communicate with the computer, you need to make use of programming language. Okay, so this is how the programming language can be classified, or the computer programming language can be classified. These are the three major classification: machine language, assembly language, and high level language. So this is how we can classify computer programming language. So we shall see one by one what do you mean by machine language. Machine language, it consists of only two symbols, that is 1 and 0. Machine language means it is machine understandable language. Any instruction you write in this machine language, it will be in terms of zeros and ones. So it is hard to code machine language. So it is very difficult to remember that binary pattern to write the instructions of your program. So this is the drawback of machine language. So in machine language, it will be zeros and ones used to write the instructions. That is, it will be in the binary form, which is machine understandable language, and the computer can easily understand the machine language. But it is hard for the programmer to write the code given with the problem in machine language. So all the binary patterns have to be remembered to write the instructions of the program. And one advantage of machine language is it doesn't require any translator program, since it will be in binary form, in the machine understandable language form. No need of any translator, since it's already in the machine understandable form. So this is about machine language. It will be the in the binary form. Okay. Coming to the next language, that is assembly language. In assembly language, we make use of mnemonics or opcodes. So mnemonics or opcodes means, say for example, you want to perform subtraction operation. So the processor may support a mnemonic, say sub. So some addition operation is to be performed. The processor may support add, etc. So these are called as mnemonics. So in assembly language, mnemonics are used to specify the instruction. In addition to mnemonics, we'll also specify the operands. Okay, remember, compared to machine language, coding the program in assembly language is easier. But what is the drawback is, since it is not in the machine understandable language, a translator program is required. A system software or a language translator is required, which is assembler, to translate this assembly language code to machine understandable language. Okay, and the drawback of these two languages, machine language and assembly languages, they are not portable. So kindly note, the machine language and assembly language are not portable, meaning whatever the program you have written for one machine, it cannot run on the other machine. So this is the drawback of these two low level languages. So majorly we classify the computer languages into low level and high level. The low level language can be in turn classified into machine language and assembly language. See, remember, low level languages are not portable. So that means a program written on one machine cannot run on the other machine. So this is the drawback in these two. So next comes this high level language. This high level language is actually programmer friendly language, we can say. So machine language, it is a system friendly language or machine friendly language, we can say. Whereas high level language is programmer friendly language, where the instructions of the program will be written which are easily understandable and which are close to the human language. So the drawback here is, drawback in the sense, directly the machine cannot understand this high level language. It requires a language translator named say compiler or interpreter. It requires to convert high level language to machine understandable language. So the main advantage of high level languages, it is highly portable. So whatever the program written in high level language, they are highly portable, means you can say they are machine independent. The program written on one machine can run on another machine with little or no modification at all. So this is the main advantage of high level language. So few high level languages are say C, C++, Java, Python, etc. So this is about computer languages. Hope it is clear. We require computer language for communicating with the computer. Computer languages are classified into machine language, assembly language, and high level language. Machine language or machine understandable language, where the instructions are written in binary form. binary bit pattern is used, zeros and ones. It doesn't require any translator since it is directly understood by the computer. Assembly language makes use of mnemonics or the opcodes. Each instruction will be written using those mnemonics in addition to the operands. It requires a translator program to translate assembly language to machine language. Okay, but this machine language and assembly language, which are called as low-level languages, they are non-portable. Okay, that means program written on one machine cannot be executed or run on another machine. Whereas high-level language, which is programmer-friendly language, whatever the instructions or statements you write in high-level language is easily understood and it is close to human language, but it requires a compiler, a translator program to convert high-level language to machine language. But the main advantage of high-level language is it is highly portable. So these are the features you can list out with respect to each of these programming languages. So this completes programming language. So in today's class, we have discussed what a computer is, what are the functional units of a computer. We discussed about hardware and software, how software is classified, that is system software and application software, few system softwares and application softwares we listed, and then we discussed about the classification of programming languages, that is machine language, assembly language, and high level language.